In today's video, we're going to build a homemade air conditioner using very few components. Stay until the end. To begin, we'll need a copper tube with a 4 by 6 millimeter diameter. Using something round like this paint can, we'll bend the copper into a spiral. What we're creating is a real miniature refrigeration system capable of lowering the air temperature down to minus 10 degrees Celsius, or to chill some drinks in just a few minutes. Once we have about 8 loops, we proceed to cut the tube and slightly bend the ends so we can connect them later on. This tube, thanks to its excellent thermal conductivity, will serve as our evaporator. Now we're going to create a second circuit with the remaining copper tube. We'll bend this second tube with a wider spacing and fewer turns. Will it be the condenser unit? Now we're going to attach the components to this small wooden structure. We've already made the holes we'll need, but you can drill them to fit your own parts. We're going to attach some plastic supports to hold the tubes in place. First, we'll secure the evaporator tube. A few zip ties will be enough to fasten our conduit. We insert the zip ties through the supports to hold the tubes. And then we'll secure the evaporator. I always love this part of the videos. The sound of the zip ties fascinates me. There it is. Now we're going to secure the condenser. Pay attention to how the inlet and outlet tubes are oriented. Now we're going to take a copper tube called a capillary tube. This small tube will create a sudden pressure drop in the evaporator, which will produce the cooling effect. We'll bend it using a pen. 2 or 3 turns will be enough. We're going to insert the capillary tube into the end of the condenser and the other side into the evaporator. Flatten the 2 sides to fix the capillary. To avoid gas leaks, we solder the ends with tin using a soldering iron. Now that we have the circuit assembled, we're going to add a small and inexpensive 12-volt fan. We'll mount it to the base next to the evaporator. Air will flow through the conduit. Now we're going to install a small battery holder. And next to this holder, another one that will support an air pump. We'll cut a PVC tube into 2 pieces and connect them to the outlets of the condenser and the evaporator. Then we'll place a 12-volt air pump on the previously installed support. Now we connect the pump outlet to the condenser and the inlet to the evaporator. And we'll connect both the air pump and the fan to the battery mounted on the wooden base. With this small 9-volt battery, it will be enough to start up our portable air conditioner, and we'll be able to cool off during the hot summer nights. We check if it works, and yes, the pump activates when we turn on the battery. Now we're going to charge our circuit with isobutane. The heart of the system is the refrigeration cycle, and although it might seem complex, it's actually based on a simple physical principle, using a gas that, when evaporating, absorbs heat from the environment. That gas is isobutane, and it's going to be our ally in turning hot air into cold air. We'll use a syringe to inject the gas into the circuit. When isobutane changes from liquid to gas, it needs energy to do so, and that energy is drawn from the heat in the surrounding air. That heat transfer is what cools the system, and to make the gas evaporate in a controlled way, we circulate it through a capillary tube, a very narrow conduit that causes a sudden pressure drop in the evaporator. As the pressure drops, the isobutane also drops in temperature and evaporates rapidly, cooling the tube through which it passes. This tube, usually made of copper due to its excellent thermal conductivity, acts as the evaporator. If we blow air through it with a fan, that air cools down instantly. But the cycle doesn't end there. Once the gas evaporates, it needs to become liquid again to repeat the process. That's where the pump comes in, simulating the role of a compressor. It collects the low-pressure gas and compresses it, increasing its temperature. Then, as it passes through another section of the circuit, the gas releases that heat into the environment and condenses. It becomes liquid again, and the circuit is complete. We now have our air conditioning unit completed and ready to start cooling the room. Let's connect our battery. As you can see, the tubes freeze quickly, reaching -10 degrees Celsius. And the fan will blow a stream of cold air that will help cool any room in just a few minutes. In the first measurements, we get temperatures of -7 degrees Celsius. But if we give it some time, we'll see the tubing get colder and colder. Until finally, there it is, -10. No more suffering in the heat this summer just because you can't afford a commercial air conditioner. Leave a comment if you've built your own air conditioner, or if you know of a more effective system. Remember to hit like and the notification bell to stay updated on all our latest content. Thanks for watching.